What is the net charge of the peptide composed of the amino acids lysine, tyrosine, cysteine, and arginine at a pH of 5.5? Let me know what you think the answer is in the comments below as I explain it. So to answer this question, you need to know the side chains of these amino acids: lysine, tyrosine, cysteine, and arginine. However, for this question, you should ignore the side chains of the two middle amino acids, tyrosine and cysteine. Now, why would you ignore these? You're going to ignore these because they are not attached to a nitrogen or carboxy terminal, which is from N to C. The 5 to 3 end is how peptides are built. So you only take the outer amino acids, which in this case are going to be lysine and arginine. Starting with lysine. Lysine has a pKa side chain of 10.5, meaning if you put this in a solution with a pH of 5.5, it is going to be protonated because a pH of 5.5 is much more acidic than 10.5. And because it is protonated, that means this will give us a +1 charge for the amino acid lysine. Now, if we look at the amino acid arginine, arginine has a side chain of 12. So once again, if you put that in a pH of 5.5, it's also going to become protonated, meaning it has an overall net charge of +1, making a total of 2 with lysine and arginine. Now, if you look at the carboxy and nitrogen terminal of every single peptide, the nitrogen terminal, the N terminal, is always going to have a pKa of 9, and the carboxy terminal, the C terminal, is always going to have a pKa of 2. The nitrogenous end of this peptide, which has a pKa of 9, is it going to be protonated or deprotonated in a pH of 5.5? So in a pH of 5.5, it's going to be protonated because pH of 5.5 is much more acidic than the basic pH of 9. However, if you look at the carboxy terminal that has a pKa of 2, this is going to become deprotonated because a pKa of 2 is much more acidic than a 5.5. Now, if we count all the net charges, we got the C terminal, which is going to have a negative charge. Then the nitrogen terminal is going to have a positive charge. And the two amino acids at the beginning and end of the peptide, lysine and arginine, are also going to have 2 positive charges. So we have the 2 positive charges from the amino acids, then the 1 positive charge from the nitrogen gives us a total of 3. Then from the carboxy end, we have a negative charge. So that's going to give us a total net charge of 2, making C the correct answer.